हरिः कर्ता।
Now let's try to find out the correlation between various features, and this is a computing correlation coefficients. So as we have discussed earlier, feature relationship analysis, the first step in feature relationship analysis is to calculate the correlation coefficients between pairs of features. So correlation coefficients measure the strength and direction of the linear relationship between two variables. The most commonly used correlation coefficient is the Pearson correlation coefficient. That's what even we have done a few examples for that. Pearson correlation coefficient, which basically ranges from -1 to 1. A value close to 1 indicates a strong positive correlation, and close to -1 indicates a strong negative correlation, and close to 0 indicates a little or no correlation. And if you see on the screen, you can see the correlation coefficient matrix. So what's the correlation? The correlation between exam marks and studying hours is 0.82, and IQ score and studying hours is 0.48. Sleeping hours and studying hours, obviously it would be completely different. School's rating is 0.36. That's also affecting some extent. Exam marks 0.82, studying hours and exam marks 0.82, positive correlation, and IQ score 0.33, positive correlation, certain extent not very strong, and schools rating 0.23, and IQ score not much. There is not much of a relation other than in exam scores you have 0.33. Sleeping hours, it doesn't make any sense, almost no relation, no relation. Then schools rating, it makes some sense when it comes to studying hours. Maybe in the school which has a higher rating will make students to buy heart more, will make students to spend more time in by hearting the question and answers. So that could be the reason of the moderate or low uh, positive correlation between studying hours and school's rating. Anyhow, let's take one example. So correlation coefficient matrix. Okay, so let's import pandas first. As PD, pandas as PD. So then let's load the data set. So let me call data is equal to pandas dot read CSV, and we got let me look for the data. That's wine.csv, and this is our data set. It's going to take some time because it has a huge amount of data set, and that here you can see that. You can just scroll right to see total number of columns, and you can just scroll down to see total number of rows or observations we have. Total we have 6,496, and these many rows we have, and when it comes to columns we have these many. Okay, let's see step. Now let's bring up the columns, what all columns we have. So columns, let me convert this into to list, and so we got these many columns, acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol, quality, color. Okay, this is what the overall data set, and you can see the respective data points and total number of observations also we can see, and this is the overall data set. Okay, just to want to have a data type, data dot details, and all are by and large float 64. Quality is int64. We have color, which is object. Let me check. Okay, we got the color, which is an object. So, and let me check the color unique values. So, data unique. So, red and white, only two. So, let me get it in unique if you want just two. But anyway, however, we can make it, we can easily make out. Okay, so that's what red and white. So this can be encoded, but that we'll see it later. For now, other than that, we will take up the remaining data points. Let's take out that categorical variable. So other than that categorical variable, we'll take up the remaining data. So data 1 is equal to data dot iloc, and let me put so data 1. Yeah, let's wait for some time. Yeah, so now I don't think we have the last column, so let me just cross check. Yep, the quality. So, and let me check the object type, d types. Sorry, let's, yeah, yes, we got the float 64s and int 64. That's it. So this is our data set. Now it's ready. So now I can go for the correlation. So correlation coefficient mat is equal to data 1 dot core okay, so we got that. Let me print correlation coefficient mat, and this is what we got, and this is huge. In fact, it doesn't make much sense because it's all clustered together. Okay, let's make it much simpler. So it can take 5 or 6. So let me bring it down to 5. So let me say data 2 is equals to data 1 dot iloc, and let me take from 1 to, okay, what is that? First one is first column is fixed dot acidity. Let me remove that. And 1 to 6, and data 2 dot columns. Okay, acidity is citric acid, residual sugar, chlorides, sulfur dioxide. This is more than enough. So now let me just copy this. Mat 2 to data 2. And here it is. It makes more sense. So if you see, okay, most of the relations are negative relations, and we could not find even one strong correlation. So let's see. Of course, the statistical significance of these relations has to be tested using t-tests, or maybe g-test or f-test or case, obviously, or you can go for the ANOVA, whatever. It depends upon the data type. The tests or statistical tests you have to use. Okay, so volatile acidity and acid, it's a negative correlation. Sugar and acidity, obviously negative. chlorides and acidity, as there is some amount of positive correlation. It's not high, it's not medium, it's a low positive correlation. The strength is low. And sulfur dioxide and acidity, it's again negative correlation. Acid and acidity, negative correlation. Mostly if you see, there is only here it's slightly better, a moderate correlation between sulfur dioxide and sugar. Then here we have the sugar and sulfur dioxide. Obviously same number will get 40287 because it's a combination. A combination either way will have a same value. It doesn't matter. Okay. So that's it. And here you have chlorides and acidity and 0.377. It's slightly better, but some extent it's okay. It's fine. What I'm gonna do is this time I'm gonna bring from 6 to last one, and let's see, will we find any better correlation here? And obviously whatever you see, okay, slightly better. You got the 0.444, which could be 0.45. Let's take it as a moderate. And here you see that perfect 0.68 negative correlation. Whether it is positive or negative, the strength is better. This one is better. Obviously, density and alcohol. Oh, obviously, alcohol density. It's opposite. The density of alcohol, they're inversely proportional, and that you can see there is a negative correlation. It's a pretty like above moderate uh, negative correlation here. And you got the 0.45 moderate correlation. That's a positive correlation between alcohol and quality. Okay, that's okay. Rest all you can see 0.03, no correlation, no correlation. And here you got the no correlation and no correlation, quality and sulfur dioxide. And density, obviously no correlation other than with this alcohol. And pH, okay, again you find no correlation. But this is how we will check the correlation between the features. Basically, that's what we want to check, the correlation between the features, and we will create a correlation coefficient matrix. And the first step of feature relation analysis is to create a correlation coefficient matrix.